if our circumference is 10 pi, that meant that our circumference would equal 2 times pi times r, or, okay, I get it, there's a drum, thank you, or pi times the diameter. Well, that means that 10 pi is that. So what's your diameter? 10. What's your radius?
10.
Wait, hold on.
Means the same thing.
Do that
So we're not doing 10 or 11.
Do that again.
No, the area ones.
It's like,
Yeah, that's 10, 11, sorry.
it's
So
like,
if your circumference is,
Oh, because you guys.
ladies and gentlemen, hold on. If your circumference is given to you at 10 pi, remember the formula for circumference is either 2 pi r or pi times diameter. What I'm doing here is knowing that the circumference is 10 pi, that has to equal pi times the diameter. Since there's pi on both sides, you can divide it out and it goes away, which means 10 is your diameter, which means that 5 is the radius.
So like 16, maybe 8.
Yep,
Got it.
that's it. That's all it was. Okay. All right, come on. Ms. Parrish?
We never did area, right?
Correct.
Okay, so I looked up how to do it last night. Is there like a formula for it?
Pi r squared.
Oh, I got 8 equals circumference squared divided by 4 pi. When I looked up how to do it.
So you said area was
Wait, Zach, is area going to be on?
not tomorrow.
Like the circumference squared over 4 times pi.
Yes, because if you square that, you get, and this is, I've never seen it written like that. That's a weird, because you get 4 pi squared r squared divided by 4 pi. The 4's drop out, and one of the pi's drop out, and you're left with pi r squared.
That's what I get.
Don't worry about it. When we get to areas later on, you probably got weird decimals because of you might not have used the fraction bar. Or when you square stuff with pi in it, if you're multiplying all that together, sometimes the calculator keeps pi, sometimes it doesn't. Just remember it's just going to be pi r squared. We'll talk about it in a couple of weeks. So don't worry about it. It won't be out there.
I got a question going back to this.
Yeah.
So,
So, all right, going back to this. If circumference is 10 pi, that means that 10 pi has to equal 2 times pi times the radius. You agree on that?
Yes.
How do you get the radius by itself? You divide by 2 pi. What's pi divided by pi?
Pi.
1.
1.
And what's 10 divided by 2?
5. 5 pi. Radius is 5.
You're overthinking.
yeah.
Just,
Been a while.
just double the radius and slap a pi next to it. Okay? Shall we?
Number 14.
So that means 13 is 8.
What? Her, you and Charlie.
So this one here, it's asking you to find the, oops, it didn't work. It's asking you to find the arc length. Now, arc length is found by our formula. Central angle, once this works, third time's the charm. You have your central angle over 360 times 2 pi r. Fill in the blanks. We know that our angle is 270 over 360 times 2 times 4 times pi. And you're right, this does kind of look a lot easier than it should be. Zeros drop, 4 goes into here 9 times. 9 goes into 27 3 times. 3 times 2 is 6, and you get 6 pi.
You did it the way
You have a calculator?
You can just put it all in.
You put it in the calculator, and it would give you the answer of 6 pi.
Oh, okay, so it was like SEC.
Yes, ma'am. Yeah, it is quite literally that quick. All right. Slow your brain down. Seriously, slow your brain down. It's a lot of it is that fast.
Oh.
Okay. Is that? One of the things that I noticed from yesterday, that as I was going through the problems last night to make up that answer key, one of the ones that I thought that most of you guys might screw up was in fact number 20. Oh yeah, remember how I told you I was going to have a worked out solution key for you guys?
Yeah.
Let me tell you real quick where I'm going to put it. When I get that worked out solution key, I'm going to put it on the calendar. So when you click on the calendar, I'll put a little attachment in here, and it'll say, you know, worked out solution key for review packet, or chapter 10 solution key, or something along those lines. And I'll have that posted next hour when during lunch. So I just scanned it last hour. I just got to upload it to the drive and then pop it up there. So it'll take a couple minutes, but I should have it up there within a half hour after class. It's not too much of a hassle. And what I did was I did my best to work out the answers in a way that I do it in class. I try not to skip steps like sometimes I can. So I wrote it out kind of long form with some of the steps there, so that way it should be easy enough to follow. Okay. Come tomorrow, then if you've got last second questions, just swing in the morning. I'll be here. Just if you couldn't get something to work right, just stop on in. It's more often than not, I know exactly what you're going to screw up. It's the distributing the negative to the far term, or it's not combining out the right terms on a question like this. So if I'm looking at number 20, number 20 is making you do two things in order to set the problem up. One of the first things that it's telling you to do is that you have an inscribed angle at, here I'm just holding on to this. You have to leave at some point in time. You have an inscribed angle at T. So when you have an inscribed angle, your angle is equal to half of the arc. So to work from the angle to the arc, what do you do to get the arc? Double.
Oh, yeah.
Okay.
So you just double it.
So I would double.
Set it out to basically.
I double the 8x plus 18, and that guy goes here. Now, how many degrees then are in a circle? 360. So I'm going to take my 2 times 8, which is 16x, plus 36, plus 6x, plus 16, plus 9x, minus 2, and set it equal to 360.
Is there a shorter way? Can you just argue
No.
fine?
There is no shorter. Unfortunately, there's no shorter way to do that because you don't know what any of the angle measurements are in order to figure out the other ones. You don't know what the arc measurements are to get there. So unfortunately, no. So 16 and 6 is 22. 22 and 9 is 31. 36 and 16 is 52. 52 minus 2 is? Bless you. And again, you'll notice once you get everything together, you can probably already see that it works out to be rather nicely. Okay. Subtract the 50, and you have 31x is 310. Yeah. And then just substituting back in. Okay. That's the kind of idea. Remember, a lot of these geometry problems, it's not just solve for x, it's a lot of solve for x, then go back and substitute in because, math, exactly. Yes, ma'am. Oh, careful though. Where's your hypotenuse?
Just have it in. They just go up and down. They just bow their heads.
All right. Does that make sense on that? Okay. So let's continue on. Let's continue on with where we were at about angles and arcs and stuff. Now, the next kind of bunch of things that we talked about was, I think 10.4. I honestly, actually, I know one thing we forgot to talk about in 10.3, I believe, was tangent segments. Segments are tangent to a circle if and only if they touch the circle at one spot. So if you have two segments that are tangent that start on the outside of the circle, that means that both those segments are perpendicular to a radius. It also means that those two segments from that, what we call common external point, have to be congruent. Okay? Those two spots have to be congruent, and the reason that that works is, well, radii are congruent, that's reflexive, and you have hypotenuse, leg, because of the right triangles. That's why that works. So anytime you are tangent to a circle, you create a right angle at the radius, and if you're tangent to a circle starting from some endpoint going to two spots, those two lengths will always, always, always be congruent. That was kind of the last bit, I think, of 10.3 that we didn't talk about yesterday, but then we got into 10.4, and then 10.4 talked about inscribed angles, which we did a few of today. Yes, ma'am?
I have one more question.
Yeah.
Um,
Oh, okay. I'm actually talking about inscribed angles right now. I'll bring that one up in 1 second. Okay. So when we talk about what are called inscribed angles are angles that lie on the circle, and that angle is always equal to half of the arc it hits. So the angle is half the arc. Okay. Also, if an angle is inscribed, if an angle is inscribed and it hits a diameter, what does that angle have to be? 90. Very good. If an angle is inscribed and it hits a diameter, it automatically, by rule, is half of the arc. Well, a diameter creates a 180-degree arc, which means half of that is always 90, so it always works. Now, the other thing that happens in here, is that sometimes when you have a circle, you can inscribe what's called a quadrilateral. Now, a quadrilateral can be inscribed in a circle if and only if, remember, if the opposite angles are supplementary. That didn't show up very often for us, but what did was using this angle here and working its way out to here. It would be half of the arc, and so on. We did that quite often. So quadrilaterals, opposite angles in a quadrilateral in a circle are supplementary. So it wasn't one that showed up always, but it's one of those that it's a nice little trick to remember just in case in class. Jana, what number was that again? 18. So it's kind of similar to what, if you go back to number 18 then, it's utilizing, not that it's a quadrilateral, but it's utilizing the idea that you have a right angle because it's a diameter. So if I look at that, oops, I know that angle M has to be a right angle. It then tells me that I have a 40-degree angle at L. What's left over for at N? 50. So, exactly. Though. Since that is on the circle, do you have your sheet? You might want to take it out and write things down. It'd be a good idea. Since you're on the circle, you work your way out to the arc, and you double it, and you get... Does that make sense? I don't know if we did one like that yesterday. It's one of those things. So there's a lot. But as you see, it's not tough.
Yeah, it's not.
It's just, you just gotta, yeah, it's a lot of visualization, of how does the problem work out? How does it go? I know that a lot of times in the instructions here, it states, if a segment appears to be a diameter, go ahead and let it be a diameter. If a segment appears to be a tangent, go ahead and assume that it's a tangent. Excuse me. And then, into 10.5, we started talking about the three versions of angles. In 10.5, we had the formulas for whether your angles met outside, inside, or on the circle. We had outside, inside, and on. That's when we had to worry about the angle measures depending upon where the vertices of the angle lie. And in this case, there was really only one tricky thing, and that was with the outside. And yes, sir.
For the testimony, are we gonna be able to solve it out?
No.
So we gotta figure out all the process.
Yeah, but if you think about it, like you just said, it's just a lot of visualization. Okay. You'd be surprised at how much you
I
really
mean,
do know.
it's a lot of visualization, but it's hard to remember like which one of these are like half.
But here's the thing: if you do an addition between it, you wind up with a negative angle, and that way you knew that you done goofed.
So that means that's switched up.
Yeah. You could wind up with. You could wind up. Think of it this way: when something's far, you want to bring it closer. How do you move things to get you closer? You subtract. So if I had a rope and I'm lassoing, I'm going to bring you closer. So I'm subtracting the distance from us.
Wait, but what is? I'm so confused on why. What does that
So here's where, believe me, I'm trying to figure out where I'm going with it too. So it takes two of us. So if my angle is here, so if my angle is here, it's going to equal half of the far away minus the close away.
That was nice.
My angle is half the far minus the close. So think of it this way. If your angle is so far away, which means it's outside the circle, and you want to get that circle closer to you, you want to bring it closer to you. So when you want to bring it closer to you, you're going to grab it and subtract the distance. And now it's closer.
I get you now.
You'll never forget that.
I won't now. Tomorrow, no, I'm like, what is it?
All of a sudden,
So when y'all see me do this learning test, y'all know the problem I'm on.
I got nothing, guys.
Let's just call it, instead of the out, we're gonna call it the lasso. AKA the lasso. I said AKA.
When you are inside the circle, if you are inside the circle, just think of an average. Now, when you have inside the circle, that means two lines intersected. And we all know when two lines intersect, you get four angles. Of those four angles, there's usually only two different measures, unless they're 90. And the reason that works is because of vertical angles. So if I put that angle there, that angle is looking at one arc. I'm doing angles. I'm not segments yet. I'm getting there.
Sorry.
It's okay.
I was jumping ahead.
I'm looking at this angle here. I'm sorry, I'm looking at this arc. But then by vertical angle, I'm also looking at this arc. So when they are inside, remember, when they are inside, think of it as the two lines they cross each other, which kind of, if you turn your head sideways, looks like a plus sign. You see where I'm going there.
He's good.
Real good.
He's
Oh,
good.
man.
No.
Arc plus arc equals.
College needs to hire this man.
I don't want to teach
Oh,
college.
these you just jump kind of.
You all paid Professor. Professor Murphy.
Absolutely.
What's wrong with the kid?
Absolutely not. I have no interest. I taught classes at Kish for a couple of years. I have no interest in teaching college.
Is it boring?
Yeah.
Too free.
Can't
why?
tell jokes.
Is it because they don't show emotion?
They know what?
College kids, they don't show emotion?
No, I just
Did they not understand?
Wait, do you have like a big class?
He said you didn't understand.
no. I mean, I had a couple. I had like a 99 on 101s and stuff like that. It wasn't crazy. I don't know. I'd rather be in high school. I didn't want to. It wasn't. It was okay. It's just, I enjoyed this more.
Because that's when you peaked.
What's that?
You can't do all this in college.
I could, I guess, but
Would you teach at Oxford?
Would you teach at the academy?
Oxford Academy? They're like the smartest people in the world. I feel like it'd be fun.
on the circle. So when you're, we changed the subject here.
I know this one.
What is it?
Isn't it half?
Yeah. And it's half the arc because remember, whenever your angle lies on the circle, whether it winds up being an inscribed angle or an angle that looks like that, if it touches the circle at just one spot, it will always, always, always equal half of whatever arc it hits. So here it's just a matter of following the arc up and around to get there. So the angle is half the arc. I know that I promised you guys a video not too long ago. How many of you guys have just finished Of Mice and Men?
Oh, yeah.
Sorry about that. So then we had segments. And guys, we only have a few minutes. I want to. Segments are what we just finished between Monday and Tuesday. Outside hole, chunk, 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 and tangent squared. That's all just from 2 days ago. So you had your outside hole is the outside times the hole. You had your parts for the inside. And then you had the tangent part squared equaled the outside times the hole. And those came from these three pictures. Okay. That's what those things, that was what we did Monday and Tuesday. And remember on Tuesday during the day, we just stopped and we did a bunch of factoring. So the factoring stuff that we have, or that we have had, or that we have walked through, hasn't been all that terrible bad, okay? The only other last bit that we did not review right now is the equation of a circle. So real fast, and I'm going to go, I just want to write out the equation of the circle and show you guys that, because remember we did that on the half day, and it took us 4 minutes. So let's take 2 minutes to review that, and then I'm going to do a factoring problem with one of these real quick, okay?
Okay.
So the equations of a circle bless you, always look like this. The quantity x minus h squared plus the quantity y minus k squared equals r squared. Where this value of h and k, where this h and k is the center, and r is the radius. All right. Thanks. So when you have these values of h and k, it is just that horizontal and vertical. It's basically what goes with what. Remember, h values go horizontally, which means they go with the x's, and the k's go vertically, so they go with the y's. Plus h comes in the alphabet before k, x comes before y. It's kind of convenient how that works. So what'll happen then is that you could have, let's say you had an ordered pair of -2 and 3 and a radius of 6. If I wanted to write out that equation then is, well, h is -3, so I put in x minus -3, which is x plus 3. I'm sorry, 2. I meant to say 2. Be x plus 2 quantity squared, y minus 3 quantity squared, and we'd say equals 6 squared, but what's 6 squared? And you're done. We did that in that half day, and we flew right through it. It wasn't anything terrible at all. I think there's, here, it's like your center would be 6, 7, and your radius would be 3. That's all. Okay. Now back to the one that had a factoring to it. If I'm not mistaken, I think.
I know the Heat stuck in my head.
32. Let's look at 32 real quick because that had a factoring to it. Yes, sir. Good question. So in this one here, we have we're going to wind up with a factoring part because we have an outside hole and an outside hole. So we take the outside of x, the whole thing is x plus 5, equals the outside of 6, and the whole thing is 6 plus 8, which is 14. Okay. Distribute through, we're going to get x squared plus 5x is going to equal 484, I believe?
Yeah.
Subtract 84.
Correct. Subtract the 84, we get x squared plus 5x minus 84 is 0. So now I got to figure out what times what's negative 84, but it adds to 5. So I know 6 and 14 work. So try the next even numbers. Try 12. I don't know, does 12 work? 14 and 12. 12 times, well, it's 7, isn't it? Oh, look at that. All I'm doing is just guessing. I'm guessing and checking. Yep. Which means I'll have a positive 12 and a negative 7. So you'll have x plus 12, x minus 7, which give you, that generates the terms. Terms therefore give you your zeros at negative 12 and 7. Which one works?
7.
Okay.
Oh, I'm too proud of 7.
Yes, sir.
Would it always be the same, the negative number?
Sometimes you might have something where, let's say the answer was negative 1. What if that chunk was x plus 3? It could theoretically work because negative 1 plus 3 is 2, so it could work. I think more often than not it doesn't, but don't always assume that it won't. You know what I mean? It could be one of those things. So. Try to knock through as much as you can. I will have answers up for you probably within the next 20-25 minutes or so. That way you can start verifying your work and put it through from there. Oh, this? Oh, I was going to the answers. I'm sorry if I, corrupted your brain by watching those. So if you have bad nightmares, it wasn't my fault.
I was told that I need to show you this.
Yeah, I gave them
Oh, because he's on Broadway. Tell him congrats. That's awesome.
Oh, you talking about the bring it here? Yes, it is. It is that song.
Looking at those.